वेलकम बैक एवरीवन। तो ये वीडियो 5 से 10 मिनट का होगा। इसमें व्हाट आई वांट टू डू इज दैट वी आर एबल टू इंट्यूटिवली अंडरस्टैंड these 6 crystal systems that we have and the 32 point groups that we have. Also, what are the relationship with the point groups with the crystal systems? Okay, तो ये जो information है ना कि 6 crystal systems क्या है, तो अगर हम याद करें we have ट्राइक्लिनिक के लिए हमको उसका एक्सियल रेशियो याद करना है और उसका एक्सिस का लेंथ का रेशियो भी याद करना है। हर क्रिस्टल सिस्टम के लिए ये दो चीज़ें हमको याद करनी है। 32 पॉइंट ग्रुप्स में तो हमको 32 इंडिविजुअल आइटम्स याद करने ही है और फिर इन दोनों का रिलेशनशिप भी याद करना है। तो इफ़ यू आर जस्ट बेसिंग योर प्रिपरेशन ऑन मगिंग ऑल दीज थिंग्स देन दैट इज फाइन, बट आई विल ट्राई टू पुट फॉरवर्ड a very intuitive line of thought so that you can understand why there are 6 systems and what are these ratios even without not mugging anything up. Okay, I hope this is helpful for you and you can follow my line of thought. So let us begin with the case of highest symmetry. Okay, let us imagine that you have a fourfold axis right here. You kept the fourfold as the vertical. फिर हमने क्या किया, हमने एक फोरफोल्ड और रखा है एज द हॉरिजॉन्टल, दीज टू बीइंग परपेंडिकुलर टू ईच अदर। तो ये वाला वर्टिकल है और ये हॉरिजॉन्टल प्लेन है। ओके, अब इफ आई लुक एट दिस ऑब्जेक्ट फ्रॉम द टॉप एंड आई ड्रॉ द टॉप व्यू, तो हाउ विल दिस लुक? दिस विल लुक लाइक अ स्क्वायर. Why will this look like a square? Because square is the representation of a fourfold axis. Okay, all these are generated using this fourfold axis. If I look in this direction and call this the front view and I draw this front view, how will this look? ये भी हमारा एक स्क्वायर की तरह दिखेगा. Why? Again, because we are talking about a fourfold axis, right? This edge is shared between both the front view and the top view. Okay, so both of these are of the length A, and because this is a square, everything is of length A, and same happens here. So if you imagine this object in 3-dimensional, what you will see is that this is actually a cube. Okay, with the side A, right? Are you able to follow the line of thought? Now what you do, you take on the length of all the axes. So if the axes are represented by A, B and C, you can see all of them are of the same length. Also, you take the angles of the top face, you can see all the angles are at 90 degree. In the front view as well, it was still 90 degrees. In the cube, all the angles of the faces are at 90. So we know that every angle also in this system would have an angle of 90 degrees. This is the definition of an isometric system. Okay. Now let us move on to the next system. So we started with the highest symmetry. Now what I will do, I will reduce the symmetry. So हमने isometric में we kept the fourfold as the vertical. Now what we will do, instead of keeping another fourfold as the horizontal, मैं इसको twofold बना देता हूँ. Okay, so I have reduced the symmetry. Now you create the top view. The top view will still look like a square because of the fourfold that exists. Okay, so the angle is 90 between these two axes and the length is the same. Now because this is a twofold, not a fourfold, so the front view cannot be a square and the front view has to be a rectangle, because the rectangle is a form that represents the twofold axes. Now this edge is shared by the top view, so this would be of the same length and this length would be a different length. Okay, if we had a fourfold, so this length also became the same length. Now if you imagine this in 3-dimensional, this would be a cuboid, a cube but extended in this direction, right? Having length A while this length is a different length C. So now you take on the length of the crystallographic axis. They are A is equal to B, the top face, while the C axis is of a different length. What about the angles? We see that the square still has 90 degrees. Also, the rectangle also has, every angle has 90 degree. That is why all the angles are still the same, but just the c-axis is different. So when you took the isometric system and you reduce the symmetry in this fashion, which is the only fashion that is possible, you get the angle still 90, just one of the axes is reduced or extended. It changes the length. Now what we will do, we will further reduce the symmetry. How is that done? Instead of keeping the 4-4 vertical, now let us keep the 2-fold vertical as well as the horizontal. Now let us draw the top view. When you look from the top, this object will appear as a rectangle, okay, of A length, of B length. When I look from the front view, the front view becomes another rectangle. Let us say this is the C length. Now because this edge is shared, this becomes the A length again. Okay. If you imagine in 3-dimensional, this would be something like this. Okay, all the lengths being different. Still, because we are talking about rectangles, the angles are still at 90 degrees. So A, B and C are not equal to each other, while the angles are still at 90 degrees. Okay, so we started with the isometric class, we reduced the symmetry a little bit, then we reduced it by a notch again, and we get this class. This is the orthorhombic class. Okay, the last class, okay, I did not discuss it. So this is the tetragonal class. Oh, tetragonal system. Be careful when you use the term class and system. These are systems, not classes. So now, till now, I hope you are following the line of thought, and we have generated the orthorhombic as well. Now, what is the next thing we can do? We have reduced the 2-fold symmetry. We have reduced the 4-fold symmetry to a combination of 4 and 2. Then we got to a system in which there was just 2-fold symmetries left. Now what can we do? In the orthorhombic we saw there were at least 2 different 2-folds. We can further reduce the symmetry and just give the system 1 2-fold to work upon. Okay, so let us say we keep this single 2-fold as the vertical. Anything this 2-fold will work on this plane, the horizontal plane. Okay, that means anything that you draw will occur in this horizontal plane only, not above it or below it. So when you have such a 2-fold axis, what will happen? This 2-fold is perpendicular to this horizontal plane. That means the 2-fold axis is perpendicular to the horizontal plane, means that 2 of the angles are at 90 degrees to each other. The third angle is such that it is not 90. What is that third angle? That third angle is present in this horizontal plane. Okay, so if these are the 3 axes, so you have something like this. It has to be perpendicular always to these 2 lines that lie in the horizontal plane, but these 2 lines can make any angle that they want. Okay, this angle is not constrained by this 2-fold axis, just that these 2 lines have to fall in this horizontal plane on which the 2-fold is working. That is the only criteria. Okay, so when you reduce the system to just 1 2-fold, what you get is that the 2 angles become 90 and the third angle is not 90 now. And because we shifted from the orthorhombic system, we can see that the axes are still of unequal lengths. By convention, the angle that is not 90 is termed as beta, because you keep the B axis as 2-fold. So you remember that. Okay. How will this look in a 3-dimensional form? You pause this video and you try to imagine how will this situation look in a 3-dimensional form. I hope you gave it a try to imagine it in 3-dimensional form. Now let us try to draw the top view. Okay, so the top view, we have a 2-fold. Till now we were drawing the top view as a rectangle, but in this scenario it becomes a rhombus. Because to generate a rectangle at the top face, you have to keep this as well as a 2-fold. But because we don't have that 2-fold, we have to draw the top face as a rhombus. A rhombus also keeps the 2-fold intact. That is why we are doing fine. Now if you draw the front view usually would look like this. It would be a rectangle. Now you may be imagining that we could not have a rectangle as the top face, but as the front face we have a rectangle. I would like to I would like to say this, that the line of thought that we are following is not complete in its entirety. Okay, these are just very simple explanation of these concepts. In actuality, if you look at the class that we are talking about, this is 2 by m. So there is a mirror plane in the horizontal direction. So that is why this rectangle is generated. So you forget about this rectangle right now. You may look at our complete lectures and you would understand why we have a rectangle right there. So you can see, if you imagine this in 3-dimensional, you can see that because this is vertical, this is perpendicular. If this is the c-axis is perpendicular to the b-axis, as well as the c-axis is perpendicular to the a-axis. Okay, that means two of the angles are at 90 degrees. It is the third angle that is not 90, and you can change that angle as you wish. This is that angle, the angle of the rhomb. Okay, now because we reduced the symmetry from the orthorhombic class, we know that in the orthorhombic as well the ratios were not equal. So this is the crystal system that we get. This came from the orthorhombic, and now because of reduced symmetry we have one of the angles not 90, and this is termed as the monoclinic system. Now let us move on to the next system. So the next system is triclinic. Till now, till the monoclinic system, what we had that two angles were at 90, right? The third angle was not 90. Now the natural progression of logic is that one of the angles should be 90, while the rest two should not be 90 degrees, right? This is how logic should proceed, but this is not the case. In the triclinic system, all these three angles are not 90. Okay. Why is such? Any guesses? Why we don't have a crystal system in which two of the angles are not 90, while the third is at a 90-degree angle? Any guesses? It is because of the three-dimensional world that we are talking about. We are always talking about three different axes. Okay. It is possible that you keep two axes perpendicular to one axis and not perpendicular to each other, like the monoclinic that we did. But there is no way that you can keep an axis perpendicular to another axis while keeping these two different axes at random angles and keeping this axis as a two-fold rotation. Okay, this is not possible, and because we have to reduce the symmetry, we have to take this two-fold as well from the triclinic. In the monoclinic, the only symmetry element left was this two-fold. Now in the triclinic, we are taking this as well. So the triclinic does not have any symmetry. That is why you can never have any of the angle as 90 degrees. And in the triclinic, you are left with a symmetry element of 1, and in some classes, a rotation in rotoinversion of 1. So I hope you were able to follow this line of thought. We will do it once again. We started with the isometric system, with all the classes, all the axes of equal length, all the angles of equal value equal to 90 degrees. Then we moved on to the next class, that was the tetragonal. In tetragonal, what we did was we took one of the angles and one of the axes, and now it became something like this. Next, we move to the orthorhombic. In the orthorhombic, what happened? All the lengths became unequal while the angles were still 90. This is what the term ortho means. Ortho means 90. Next, what you did? You moved to the monoclinic. In the monoclinic, what you did? You made one of the angles not equal to 90 while keeping the two angles at 90 degrees. Then you reduce the symmetry even further and you landed with the triclinic system with all the angles at not 90 degrees. Also in the monoclinic, you fine. Okay, so this is what you land up in the triclinic. You started with everything equal, all the angles equal, all the lengths equal. In the triclinic, nor the lengths nor the angles are equal. There is one system that is left, that is the hexagon class. Now hexagon was not in this line of thought because it follows the angles of 120 and 60 degrees. That is why it was not shared here. So you keep this in mind, the angles in the hexagon class are such, and the axes sorry, in the hexagon the axes are labeled as A1 is equal to A2 is equal to A3, while the C axis is different and not equal to these. Okay, so I hope this was helpful.